Hey everyone, my name is Imran and welcome to day 68 of 90 Days of DevOps 2024 Community Edition. And before starting this session of mine, I would like to say thank you to Michael for giving me this opportunity. I'm a big fan of Michael's work. I've learned so many things from Michael's 90 Days of DevOps program since I've started my journey back in August 2022. And I want to say that thank you so much, Michael, for giving me this opportunity and let's start the session. So my session is about service mesh for Kubernetes, the secret sauce to effortless microservices management. It will be a beginner friendly session. So let's talk about what are the things we are going to learn about service mesh in today's session. So these are the 5 things we are going to learn today. That is, what is a service mesh, why it is needed, what are its components, its architecture, what are the benefits of service mesh, and what are the use cases and best practices for service mesh. So before starting this session, I would like to give a brief introduction about me so that you can know about me. So I'm a self-taught DevOps engineer and a Go developer who comes from a civil engineering background. I started my journey back in August 2022, and I'm also an AWS community builder right now. And I'm also the community manager and a co-founder of the growing community, which is an inclusive open source community. And I'm currently working as an associate at Delivery Limited in India. And I also like to write technical blogs. And I also believe in learning in public. So I like to share whatever I'm learning and what I'm doing in public with the community and also learn back from the community. So now let's talk about our topic, that is what is a service mesh. So service mesh is a dedicated infrastructure layer which is designed to manage, observe and control communication between microservices within a Kubernetes cluster. Service mesh helps in overall reliability, Kubernetes security and observability of the microservices that makes up a complex and distributed system and application. There are many popular open source technologies which can be used to implement service mesh in a Kubernetes cluster, such as Istio, Linkerd, and Console Connect, and many more. And now let's talk about why service mesh is needed, why it is required in a Kubernetes cluster. So first, we are going to talk about the challenges in microservices communication and its management. So microservices have platform concerns like connectivity, security, reliability, and observability. So these are the challenges which are present in Kubernetes cluster in microservices management. So now we have to talk about how a service mesh addresses these challenges in a Kubernetes cluster. So a service mesh addresses these challenges by providing built-in service discovery. It handles all the network complexities. It offers intelligent load balancing. It helps in enforcing security measures in your microservices. And it also handles the reliability. And it also enables observability for your microservices in a Kubernetes cluster. And the third thing we're going to talk about is what are the benefits of a service mesh architecture? So a service mesh offers a lot of benefits, which we are going to talk about in detail in the video ahead. But to list down, some of the benefits are it offers streamlined and simplified communication between microservices. It offers scalability and performance. It provides enhanced security. It improves your observability. It gives you efficient service discovery and fault tolerance. And it ultimately leads you to a more robust and more reliable distributed system. So next we're going to talk about the components of service mesh. So as I said earlier, there are several popular open source technologies which can implement service mesh in a Kubernetes cluster, such as Istio, Linkerd, Console Connect, and many more. So in today's session, we are going to learn about the components of a service mesh with the help of Istio. So let's talk about the components of Istio. So there are 2 components. One is data plane and another is control plane. So in data plane, it consists of Envoy proxies which are deployed as sidecars. These proxies control all the communication between microservices, and also they collect the telemetry on all the network traffic. And if we talk about the control plane consists of Istio which configures all the proxies to route and secure traffic, enforce policies, and collect telemetry on all the network. So now let's talk about the data plane or Envoy proxy. So it is an open source project. Envoy is a layer 7 proxy to move all the networking logic into a reusable container which runs as a sidecar. The proxy sits alongside a microservice and routes requests to and from other proxies. The proxies work together to intercept the communication between the microservices, and it simplifies the network. They provide common features that can be used across all different platforms, creating a data plane that allows containers and services to easily talk to each other. So now let's talk about the second component, which is control plane or Istio. So the control plane or Istio act as the brain of the service mesh. It provides control and management capabilities. Istio simplifies the management and deployment of the Istio control plane. It configures proxies to route and secure traffic, enforce security policies, and collect telemetry data. It also handles important things like service discovery, traffic management, security, reliability, observability, and configuration management in a unified manner. So now let's understand the architecture of a service mesh with this example right here. You can see on the screen. So here we have two services, service A and service B. You can see there are proxies attached to each service, and both of these proxies are connected with Istio, the control plane. So these proxies are acting as data plane. All the networking logic is stored in this data plane. So here we can see the traffic, which is the ingress traffic, which is coming. It is not communicating with the service directly, but it is going through the proxy. Then the proxy will talk to the service A. Then service A will communicate back to the proxy, and then the proxy will again talk to the second proxy, which is attached to the service B, and then the same communication will happen with proxy and service B, and then the service B will communicate back to the proxy attached to it, and the traffic will go out from the proxy. So here with this example we can see that how all the networking logic is transferred to the data plane. All the communication is happening through data plane. No service is communicating directly. All of the services are communicating via proxies, and all the configuration of these proxies happens through the control plane, which contains Istio. In this diagram you can see three other components as well, but we don't have to look after that. There is only one component, that is Istio. All these components are older components which doesn't exist anymore. These used to be separate components, but all of these components are a part of Istio. So there is only one component, that is Istio, which configures and controls all the proxies. So now that we have talked about the architecture of a service mesh, now let's move on to its benefits and its use cases. So there are a lot of benefits. I have written down a few of them. So let's go through all of the benefits and its use cases one by one. So the first benefit is service to service communication, as we are talking from the starting. So service mesh makes the communication between microservices very easy and simplified. We don't have to configure every service again and again. The second benefit is observability. So the service mesh offers comprehensive observability features like distributed tracing, logging, monitoring. It provides insights into the performance and health of a system. Next benefit is traffic management. A service mesh enables efficient traffic management, which includes load balancing, traffic shaping, routing, and it also supports A/B testing and gradual rollouts. The next benefit of a service mesh is security. It enhances security by providing built-in support for end-to-end encryption, mutual TLS, and access control policies between microservices. So the next benefit we're going to talk about is load balancing. It offers built-in load balancing capabilities such as distributing incoming requests across multiple instances of a service to ensure optimal resource utilization. The next benefit is service discovery. It simplifies service discovery by automatically registering and discovering services, which reduces the manual effort required to maintain and manage service addresses and its configuration. The next benefit we're going to talk about is consistent configuration. One of the best benefits of a service mesh is that it ensures uniformity in all the configuration and policies across all the services. We don't have to worry about managing the configuration of all the proxies. We can just configure a proxy and we can inject it again and again automatically with the help of our control plane. The next benefit we are going to talk about is policy enforcement. So it helps in enforcing policies across all the services very consistently, such as rate limiting, access control, and retry logic, without the need of modifying the code or need of changing the code in every microservice separately. And another benefit of the service mesh is it eases up scaling. It simplifies the process of scaling the services up or down by providing features like automatic load balancing, which makes it very easy to adapt for changing traffic patterns. So the next thing we're going to talk about are the best practices for a service mesh. Like, what are the best practices you can follow for the best use of a service mesh? So the first thing is incremental adoption, which means you should not go all in with the service mesh. You should adopt the service mesh gradually, starting with the non-critical services, which will also help in minimizing the risk. The second best practice is to ensure uniformity across all the services. You have to ensure consistent configuration and policies across all the services on a platform to maintain a uniform behavior. The next thing to keep in mind is monitoring and logging. You should leverage the observability features of the service mesh for monitoring, logging, and to diagnose the issue and analyze the overall performance of your system and application. The fourth best practice is strong security policies. You should implement strong security policies including mutual TLS, access control, and end-to-end encryption to protect the communication between all the microservices. The next best practice is very well known and it works around all the technologies we know, but it is very simple yet very important best practice that you should provide comprehensive and proper documentation and training for development and operations team to understand and use the service mesh effectively. The next best practice is testing. You should always consistently and constantly conduct thorough testing, including integration testing, to ensure that the service mesh behaves as you want it to and it does not cause any performance bottlenecks. The next thing you have to keep in mind is regular updates. You have to keep the service mesh components and its configuration up to date so that you can get the benefits from its latest features, improvements, and security patches. And the last best practice I'm going to talk about is performance optimization. You should regularly monitor and optimize the performance of a service mesh so that it meets the required scaling and latency targets. So these are the best practices for a service mesh which you should follow, and which takes us to the end of this session. So I hope you learned something new today and you will go deep dive into the topic of service mesh and this technology more, and it is an amazing technology. You should definitely learn about this. And thank you so much for joining this session, and I would like to say thank you to Michael for giving me this opportunity. Keep doing this amazing work, and everyone who is watching, please share this video within your community, which will help this program to grow more and reach out to more people so that they can also learn something new. And if any one of you want to connect with me, you can just connect with me on any of the socials. I would love to connect with you folks. Thank you so much. Keep learning, keep sharing, and keep growing.